Now let's look at what resultants, what sums can two vectors produce. And you can see that there are some cases in which the sum of two vectors, speaking colloquially, disappear. Like in this case, you cannot see the resultant of, you cannot see vector W now, it vanishes. Speaking mathematically, the two vectors add up, in this case, to vector 0. Vector 0 head and tail coincide. So here is an example of vector AB, and you can see that vector AB equals to 0 when point A coincides with point B. Point A equals to point B. Now, as an exercise, you can pause the presentation and show that for any vector u, so here you have vector u, vector u plus the 0 vector add up to vector u. So in order to show it, let's move vector AB so it coincides with the head of vector u, and we remember that vector AB, its tail and head coincide, so point A equals to point B, and B is the head of the 0 vector. And now vector u plus the 0 vector AB is vector whose tail is at the origin and head is equal to B, which is vector u. And this shows that u plus 0 vector equals to u. And before we showed that adding two vectors is commutative, so u plus 0 is the same as 0 plus u. And here we have the next property of vector additions. So for any vector u exists vector 0 vector, that for any vector u plus the 0 vector is the same as 0 vector plus u, and it is equal to u.